Okay, so this video is an explanation of the ballistic pendulum lab that we did today. So first, here are some of the hints that I gave you in class. So to calculate the height, here is the block with the ball already in it. It's shown at the radius r. I forget what r was, but I told you what it was. And what ends up happening is it swings out this way, and it makes the angle theta, which the ballistic pendulum recorded for you. And you can see r stays the same because the length of the string on the pendulum doesn't change. So if you draw this horizontal line from the top of the block straight over, you can then find the height that it actually climbed. That's the h that you need. Now to solve this, you need this blue line. And to get this blue line, you should remember that is the adjacent side to angle theta. So if you did r times the cosine of theta, you would get the length of that blue line. And then taking r, which is the radius length, minus r times cosine theta, you will be able to get h. So the equation you need to solve for h, the vertical height, is h equals r minus r times the cosine of theta. You need that height for the conservation of energy equation. So there's two parts to this problem, and you can think of it like two motions. In the first motion, it involves the ball getting fired into the block. The second motion involves the block with the ball inside moving from 0 degrees to whatever angle you recorded. Your answers are going to be different, so I don't have an actual angle here for the video. The second motion then is the block with the ball inside as it moves from the lowest point, which is angle 0, all the way up to whatever angle it records, and in so doing, raising that block up by a height h. So what you have to remember is gravitational force, is a conservative force, and therefore it doesn't matter that the block followed an arc path to get to the height h. It only matters that it moved from a potential of 0 to a potential of h above 0. In other words, the box lifted a height h, and that's all that matters. It doesn't matter that it followed a circular path or if it went up steps or however it made it. It doesn't matter. All that matters is the block with the ball in it is at the end of the motion, h, well, whatever h is, higher than it was. So now that you have h, you can solve the conservation of energy equation by setting U naught, which is initial potential energy, plus K naught, which is initial kinetic energy, equal to final potential energy U plus final kinetic energy K. Or if you expand them, you'll get mgh naught plus 1/2 mv naught squared equals mgh plus 1/2 mv squared. You can then cancel out the mgh naught, which is the initial potential energy, because it starts off at a height of 0. H naught is 0. We define that bottom level as 0, right? So we can cancel that out. Similarly, at the end of its motion, the block comes to a brief stop. So we can cancel out the final kinetic energy because the velocity at the top of the motion equals 0. So now you have 1/2 mv naught squared equals mgh. And what you can do now is cancel out the masses on both sides. And you're left with 1/2 you're left with 1/2 v naught squared equals gh. If you divide both sides by 1/2, you'll end up with v naught squared equals 2gh, because when you divide both sides by a half, you're actually multiplying it by 2. And then when you take the square root of both sides, you will get v naught equals the square root of 2gh. So now you have the initial velocity of the block with the ball inside of it. So now we have to look at the first motion. The first motion is the ball getting fired into the block. The ball gets shot with some speed into the block, which is initially at rest. This ends up with the ball inside the block, and now the block will swing away as one unit, which actually is the second motion. The first motion is the conservation of momentum. The ball has a mass. We'll call it m sub little b. The ball has velocity. We'll call it v sub little b. The ball therefore has initial momentum, which is the product of mass and velocity. So it's m sub little b times v sub little b. Now the block, we'll call it m sub big B, equals mass of the block, and v sub big B is the velocity of the block, but the block is at rest, and therefore v sub big B equals 0, and therefore the momentum is 0, so we can say the block has 0 initial momentum. Now at the end, mass is going to be the combined mass of the block and the ball, and what's the velocity going to be? Any ideas? The velocity is the velocity that you solved in the second motion. So if you look at this, from left to right, you're looking at the ball getting fired into the empty block, and then the ball is in the block, and it moves some height h, right? And we solved for this initial velocity using the conservation of energy. And that's the same velocity as the final velocity you use when doing the conservation of momentum equation for the first motion. Remember, the initial momenta is the ball by itself and the block by itself, and the final momentum is the block with the ball inside, which also happens to be the initial velocity for the second motion. So we know the ball has initial momentum. We know the block has no momentum, and now the ball and the block combined have a certain momentum, which is the combined mass multiplied by the velocity we already calculated, and now all we have to do is solve this equation for v sub little b, and we solve the whole problem. And that is how you solve the ballistic pendulum problem from the lab today. Hopefully you did it the same way and you got the right answer.